Hey everybody, this is the first video of day 4. As you can see from my little to-do list on the right hand side, we've got quite a few videos coming for day 4, kind of making up for the sort of low complexity, low new material from day 3. Um, a bunch of the material will hopefully be familiar, though there will be some particular cock nuances. We'll talk about some Galena cock concepts here, but overall we'll be talking about data structure. Start by talking about lists in two different ways. This video will be monomorphic lists. And then we'll talk about some other data structures as we go. And I'll conclude with a final whiteboard video about how to draw a data structure. One thing I want to call your attention to is now this little spot right here. So by request, every time I do a non sort of text command, it'll show up in there the thing that I just typed. Then to the right is the name of the actual emacs command that it ran. This bit is maybe less interesting. This is the interesting bit. Just a bit of terminology. This bit here is called the mode line. Each one of these little frames is called a frame. A frame is pointing at a buffer, but you can have more than one frame looking at a buffer. I can edit two versions of the file side by side. All together, this is a window, the thing that has that. That's at least the same name as what you. And then down here, like if I type Control X, Control F, you'll see my cursor's all the way down here at the bottom, and that's the mini buffer. And that's where you do things like enter command line stuff and things. Not gonna let me adjust the mini buffer size. So that bit's all a little bit hard to see. Knowing these names is maybe going to be useful for the course, but not so. Okay, let's get started. Um, we're going to define some data structures. We're going to start by defining lists. So I'm going to start out doing things the way we're not going to do it, just to give you a sense of what a list might look like. We're going to give a list to constructors. So let's say we wanted to have a list of natural numbers. So that list will have could be empty. So that's one constructor. We're going to call the empty list constructor nil. So I'm giving it this other name in this other module so that we can hide these experiments from the actual sort of global namespace, not polluted. Now, if we want to build up a bigger list, then we'd use cons. So this name is very old. It goes back to John McCarthy's Lisp language from the 50s and 60s. So this is nil and cons are a super, super old name for the ways you build up a list. For those of you who know something about data structure, this will be a single linked list treated as a stack. You'll learn much more about what all these things are in CS62. For now, we're just going to call these things lists. Okay, so let's start playing with these simple notions of lists. Here's a function that computes a list's length. How many elements are in a list? Well, if the list is nil, we'll return 0. If it's a cons of something, well, the length doesn't matter what the thing is. You'll notice now we're pattern matching on a constructor that has 2 arguments. So here's the syntax. Constructor name, pattern for the first argument, pattern for the second. So we're ignoring the first argument and calling L prime the tail of the list. This is super common, just the same way that you call N prime the natural number that's one less than the one you're looking at. That's like the tail of the natural number. This is the tail of the list. Okay, well, if we have a cons though, then that means we have at least one element. So we have 1 plus whatever the length of the rest is. So here's a little list. Let's look at it. Nat cons 1, nat cons 2, nat cons 0, nat nil. That list corresponds to 1, 2, 3. That's the list. The actual notation we'll get to use eventually, I think starting on day 5, we'll write something like this to mean a concrete list containing not 1, 2, 3, 1, 2, 0. Okay, so we should expect the answer for this to be 3. There are 3 elements in this list, and compute gives us the right answer. Okay, lists. Uh, you might wonder though, like, okay, but what if I wanted a list of bools? And in this regime, if we did things this way, we'd have to come up with a new type called bool list, and it would hold bools. And we'd have to redefine length, and you'll notice that this is exactly the same. We're not even looking at the bools. Like, why does it matter, right? In some sense, the type is irrelevant to computing the length of the list. Why do I have to write a bunch of multiple length functions? And there are real languages that exist today that have this problem. And it's kind of a shame, right? Like to have to do this more than once. It's like here okay, fine, we can do it, right? Okay, so true, true, false, right? That's gonna be something like this, right? This is not yet syntax we can use, but it will be. And then bool list will give us the same answer, right? Okay. In the next video, I'll show it right now, and the next video I'll start explaining the actual type of list that we'll use that works with type parameters. So we briefly saw type parameters, I think, at the end of day 2. Uh, and now we're going to start to get to see what those mean sort of in much greater detail and sort of how you work with it. By way of terminology, these lists are monomorphic. Why are they monomorphic? Well, they have one possible shape, right? So nat list can only hold nats. Cons can't hold anything else. Bool list can only hold bools. It can't hold anything else. The language you might have learned first, if it was, say, Python or JavaScript, is a little more freewheeling, right? It allows for heterogeneous lists rather than these homogeneous lists. These homogeneous lists are monomorphic. Our polymorphic lists, next kind we described, that will allow us to define the list structure once, but have it contain different elements in different lists, will be homogeneous just like these. Everything in a given list will all have the same type, but you can have different lists of different types. Okay, hopefully that was clear enough how these lists work. What may pay is skipping to the very end and watching the whiteboard if you don't understand what I've just displayed. So if these data structures I've shown so far don't make sense, once I make the whiteboard video where I do drawings of all of the different data types we have here, you'll maybe get some good connection there in terms of seeing what these symbols actually are meant to represent in our minds and on them. Okay, that's it for now. See you in the next video.